Section 7.4, Integer Exponents, Part 1 of 2. We're going to simplify. Example 1, 2 divided by 2 equals 1. Example 2, y divided by y equals 1. Example 3, a to the 7th divided by a to the 3rd. We can write it out. A times itself 7 times. And in the denominator, a times itself 3 times. And what's a divided by a? 1. A divided by a, 1. A divided by a, 1. A to the 7th divided by a to the 3rd is a to the 4th. X to the m divided by x to the n equals x to the m minus n. We subtract the exponents. The bases must be the same. R to the 8th, s to the 6th, divided by r to the 7th times s. Just look at the r's first. R to the 8th divided by r to the 7th. Subtract those exponents. That's s to the 6th divided by s to the 1st, s to the 5th. R times s to the 5th. Example 5. X to the 0 equals 1. Anything raised to the 0 power equals 1. A to the 0 equals 1. X to the 5th divided by x to the 7th. 5 x's in the numerator, 7 x's in the denominator. And remember, x divided by x is 1, 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 x divided by x is 1. 1 over x squared. There are more x's in the denominator than there are in the numerator in the original problem. Please be sure that those x's are in the denominator. X to the negative n equals 1 over x to the n. If we subtracted these, 5 minus 7 is 2. 5 minus 7 is negative 2. It's x to the negative 2, which is 1 over x squared. Example 8, x to the negative 2 equals 1 over x squared. Example 9, 3 to the negative 2 is 1 divided by 3 squared. 3 squared is 9, 1/9. Example 10, x to the 2nd divided by x to the 7th. 2 minus 7 is 5. 2 minus 7 is negative 5. Those x's need to be in the denominator, 1 over x to the 5th. Y to the 5th divided by y to the negative 3rd. The y to the negative 3rd in the denominator moves to the numerator because of that negative exponent. Just like back in example 9, where that negative 2 exponent moved the 3 squared to the denominator. The y to the negative 3 in the denominator moves it to y to the 3rd in the numerator. Y to the 5th times y to the 3rd is y to the 8th. Example 12, 2 to the negative 2 divided by 2 to the 3rd. 2 to the 3rd has a positive exponent, so it stays where it is. 2 to the negative 2 has a negative exponent, so from the numerator it's going to go to the denominator. 1 over 2 to the 3rd times 2 to the 2nd. 2 to the third is 8. 2 to the second is 4. 1 over 8 times 4 is 1 over 32. An exponential expression is in simplest form when it is written with only positive exponents. X to the fifth, y to the negative seventh is not in simplest form because of that negative exponent. X to the fifth, positive exponent, it stays in the numerator. Y to the negative seventh, to have a positive exponent, move it to the denominator. X to the fifth divided by y to the seventh. Example 14. 4 times c to the negative 3. Please note that that negative 3 exponent is with the c. It has nothing to do with the 4. 4 will stay in the numerator. C to the negative 3 moves to the denominator, and it's 4 over c to the third. B to the eighth divided by a to the negative fifth, b to the sixth. We need to simplify the b to the eighth divided by b to the sixth, and that is going to be b to the second in the numerator. A to the negative fifth in the denominator moves to the numerator, so it's a to the fifth, b to the second. 3 times x to the negative first, y to the second, divided by x to the negative second. The x to the negative 2 in the denominator moves to the numerator and becomes an x squared. Y squared stays where it is. X to the negative 1 moves to the denominator. And now we can simplify. X to the second divided by x is just x, so it's 3x y squared. That's section 7.4, Integer Exponents, Part 1.